The gain is an important performance parameter you have to consider when choosing the antenna for your connected device because it impacts the link budget between a transmitter and a receiver. If the antenna performance is not good enough, the radiated device performance will also fall short. Also keep in mind that if the power radiated by the device is reduced by 6 dB, the theoretical propagation distance is divided by 2. Thus, the service level of the device on the network will be impacted. This diagram shows a rough illustration of the link budget in ETSI-like regions. In an ideal situation, the device radiates up to 14 decibels. At the base station, the antenna gain is 5 decibels, and the receiver sensitivity is minus 142 decibels. The antenna gain adds 2 decibels in this example, so the antenna gain can slightly increase the link budget. As a conclusion, in order to benefit from an optimal link budget, it's highly important to pay great attention to the antenna design. Many antenna technologies are available. A half-wavelength antenna will usually provide you with optimal performance. It is suitable for a device that has no size or design constraints. PCB printed technology enables a high integration antenna within the board while drastically reducing the dimensions of the antenna. Wired antennas and ceramic antennas are also used for IoT devices. To sum up, what are the key design parameters of the antenna? The antenna gain is the first key parameter. It's better to have a high antenna gain than a lower or indeed a negative one. Antenna gain and efficiency are the first key parameters. The higher the antenna efficiency, the better the device radiated performance will be. A highly efficient omnidirectional antenna, for instance one with 60 to 100% efficiency, should provide a peak gain between 0 and 2.5 dBi. Keep in mind that the radio class assigned to the connected object by the Sigfox Ready certification is based on the ERP performance. The antenna matching is a second key parameter. If the antenna impedance is not matched to the chipset RF output impedance, a part of the energy coming from the chipset will be reflected instead of being accepted by the antenna. As a result, this reflected energy will not be radiated by the antenna and thus lost. Thirdly, the antenna bandwidth. Sigfox is a two-way communication service enabling devices to perform uplink and downlink communication. The uplink and downlink operation bands are not the same. They are usually separated by 1 or 2 MHz. As a consequence, the antenna must operate in both frequencies without any problem. Of course, most of the antennas in the market have a bandwidth that is much larger than 1 or 2 MHz. An antenna that covers a larger bandwidth than required will be less sensitive to the manufacturing tolerances as well as the detuning caused by the antenna environment. Therefore, it is a good idea to select an antenna which covers more than only the required bandwidth. Regarding the radiation pattern, something important to keep in mind is that Sigfox strongly suggests using omnidirectional antennas. Why is this? In fact, Sigfox implements space diversity within its network. So when a device is transmitting its radio signal, several base stations within range will receive it. The device is not aware of the base station location. It just broadcasts the message. All the base stations within range will detect the radio signal and demodulate it. To better benefit from the space diversity offered by the Sigfox network, omnidirectional antennas are highly recommended.